Our objective is to draw the shear influence line for this beam qualitatively. The beam has a collar at the left end. This support type allows vertical displacement, but no rotation at A. To build up to this, let's start with a simpler scenario. A beam that is pin-connected at its left end. We want to draw the influence line for shear at point C. In this presentation, I'll use a slightly different approach to drawing influence lines than the one presented in previous lectures. We begin by placing a vertical roller at point C, effectively removing the beam's ability to resist shear at that location. We then apply a unit shear force at C, causing the beam to lift by 1 unit, while temporarily ignoring the roller support at B. As a result, segment CBD shifts upward by 1 unit, maintaining its straightness, while segment AC remains unchanged. Needless to say, this configuration does not satisfy the beam's boundary condition at point B, as the beam cannot have vertical displacement at the roller support. To correct this, we adjust the diagram by rotating and shifting it vertically. In this case, rotating it clockwise ensures that it rests on the pin and roller supports at A and B, thereby satisfying the boundary conditions. Here is the resulting shape. Now we can determine the height of the influence line above and below the horizontal axis using simple geometry. The height-to-base ratio of this triangle equals the height-to-base ratio of this triangle. Since L1 equals L2, H1 must be equal to H2. Hence, they each equal 1/2. We can determine this height using the same approach. It equals 1/2. Now let's consider our target beam, which has a collar support at A. This support allows vertical movement, but prevents rotation. When we release the beam at C and apply a unit displacement, we obtain a similar initial diagram as before. To satisfy the boundary conditions, however, we must account for the fact that no rotation can occur at A. This means we cannot rotate the diagram to enforce the boundary condition at B. Instead, the only permissible adjustment is a vertical shift. By shifting the diagram downward until it touches point B, where the roller support is located, we satisfy both boundary conditions: no vertical displacement at B, and no rotation at A. This gives us the influence line for shear at C. The shear at C is -1 when the unit force is applied to the left of the point. Otherwise, no shear force develops at C.